Thanks for joining me at Build 2020. My name's Craig Dunn, and in this session, I want to talk to you about the Microsoft Surface Duo and dive into the technical details of bringing apps to dual-screen devices. Before we get to the technical bits, I'm going to do a bit of talking. First, I want to share some information about the Surface Duo and how anyone can develop apps for it. Then we'll cover what's unique about this dual-screen user experience, and I'll show some code as I enhance an existing Xamarin app for dual-screen devices. As always, we'll finish up with some ideas and links of where to go next. Here's a picture of the Surface Duo. There's a great intro video on Microsoft.com that you should definitely check out, which shows the Surface Duo in action. As you can see, it's a handheld dual-screen device. What isn't immediately obvious is that it runs Android, so the huge catalog of apps and games on Google Play can be installed, including Microsoft Office, the Google Suite, and a lot more. You heard right. This is Microsoft's first Android device, and it'll support all your favorite apps and games. The Surface Duo can be folded so that only a single screen is active. In that mode, it feels just like a regular phone, and apps behave just like any other mobile device. You can make calls, take photos, check your email, and play games, all on a single screen. When unfolded, apps still work, but now you can have two side by side. This opens up a whole new way of working. You can multitask and share data between apps with drag and drop, or just more easily read your emails and calendar side by side. You can also move an app to use both screens. This gives app developers the chance to build a totally new user experience with a lot more screen space. Speaking of app developers, because the Surface Duo runs Android, you can build dual-screen apps with a wide variety of developer tools and languages. Java and Kotlin are the obvious choice for existing Android developers. Using Android Studio, you can update your existing apps to take advantage of dual screens or create something new for Surface Duo. Unity developers can incorporate our native Android helper library into their games to customize the game view when it's over two screens. React Native developers can use TypeScript and JavaScript to build apps with the dual screen libraries that Microsoft has made available, and which you'll see in a different build talk on React Native. Flutter devs can integrate our Android helper library and create a channel to access device information and build Duo-friendly layouts. And web developers can check out our documentation for details on detecting and responding to dual-screen capabilities. And finally, Xamarin developers can target the Surface Duo with Xamarin Android or Xamarin.Forms using Visual Studio and C#. You can see here the food delivery dual-screen demo, which might pop up elsewhere in Build and has source available on GitHub. All of today's code demos will be using Xamarin, but the concepts, including the UX patterns I'll cover next, are applicable to all developers interested in dual-screen apps. If you're already excited and use any of these developer tools, you can get started building for Surface Duo today. Visit the documentation at docs.microsoft.com/dual-screen, and you can download the emulator preview and find many samples across a variety of platforms and languages. The docs also include an overview of dual-screen development, which covers user interface and design patterns that might be relevant for your apps. Let's talk about some of the ways that the user experience is different on a dual-screen device. First, we'll look at the postures the device can be placed in. The top row here shows the Surface Duo using a single screen. I've said before, this is similar to existing devices. You can be in portrait or landscape orientation. On a regular device, however, you can't instantly double your screen. When the Surface Duo is unfolded and using both screens, it enables the dual screen postures in the bottom row. These are new modes, and they create opportunities for new user experiences. In dual portrait or wide mode, it almost feels like you have two phones side by side. This is likely to be used for multitasking, with the two screens being used to compare or share content. In dual landscape or tall mode, it's suited to using the entire area to focus on one task, so the two screens are often used to expand the content area for a single app. Postures help us understand how people will hold and interact with the Surface Duo, but these 5 UI patterns help understand how your apps facilitate those interactions. Each of these scenarios, the dual screen offers something beyond a normal user experience, whether it's showing more information or showing related pieces of information or providing a more natural navigation or providing a more immersive reading experience. These examples can help guide new dual screen developers to build compelling apps for the Surface Duo. One or more of these patterns will likely apply to your app ideas, so I'm going to look at each one in detail. Extended canvas is a very basic concept. The app resizes to take up the additional screen. While this is the simplest dual screen pattern, it's ideal for some types of visual data. You might use this pattern if your app has a free-flowing canvas where the user is able to scroll around, like a map, or you need a bigger canvas for tasks such as drawing with touch or pen. In addition to maps and drawing, Excel-like sheets are also good candidates for this pattern. Master detail is already common in mobile and desktop apps. It consists of a master pane, usually with a list view, and a details pane for content. When an item in the master list is selected, the corresponding details are displayed. The list could be text or images or any content, really. For this pattern, it's important to consider what happens when the device is rotated into dual landscape. Users often intend to focus on the detailed content when they're in this posture, so consider hiding the master list and expanding the detail to both screens. Examples of apps that suit this style include email, to-do lists, photo browsing, and any data structure where the user is drilling down into items. Emails and documents both lend themselves well to using extended canvas when the device is rotated. Two-page is for apps that work with book-like paging. The Surface Duo already feels like a book in your hand, so it's easy and natural to consume paginated data by scrolling horizontally or page turning. E-readers are an obvious application for this pattern, but can also be used for content creation, such as a Notes app or a drawing tool, where the data is entered and navigated like a book. As with the master detail pattern, you might want to switch to the extended canvas when the device is rotated, and possibly switch from horizontal to vertical scrolling. Dual view is subtly different to master detail. In this case, the two screens provide a way to compare or contrast two versions of the same content side by side, like two image lists or two documents, or provide different perspectives on the same data. An example of the first case might be a markdown document, showing source on one side and preview rendering on the other. A good example of the second style is a restaurant booking app, where a map with markers could appear on one side and the same list of restaurants on the other screen. It's conceptually the same data, but you provided two different views for the user to manipulate and letting them dynamically choose which one they want to interact with. A key element of dual view is keeping them synchronized to reflect the changes as the user interacts with each screen. Finally, companion pane. Companion pane lends itself to exposing otherwise hidden UI that would not be as easily accessible in single screen mode. For instance, elevate hidden functionality that users can often need to the second screen. Examples could be creative tools like an image drawing app, where you can place the canvas on one screen and use the other to hold tools. Another example is gaming. Single screen devices often have the controls overlaid on the game port. But for a second screen, you can use for dedicated controls without obscuring the game action. That's enough theory. Time to put some of these ideas into practice. For the rest of the session, I'm going to enhance the Xamarin app for the Surface Duo. To get your existing apps ready for dual screen devices, we recommend a phased approach. Step 1, download the Surface Duo emulator and test your app. Use it in single screen mode, both portrait and landscape, to verify it works well in the device's aspect ratio. Then try spanning it across both screens and start to think about how you might enhance that experience. Step 2 is making incremental changes to incorporate more Android features. Additions like pen input, drag and drop support, widgets, and other Android features can benefit your users on all devices, not just Surface Duo, but they really light up with two screens. The third step is using the patterns we just talked about to implement dual screen specific navigation and interactions that really take advantage of the two screens, including having the app span across both. Let's see how this looks in practice. The app we're going to work with is straight off the Xamarin Docs site. It's called Notes, and you can find it in the Xamarin.Forms Quick Start section. You'll recall step 1 is testing, so I'm going to switch over to Visual Studio and the Surface Duo emulator for a quick look at the notes on a Surface Duo. This is the Xamarin.Forms Notes Quick Start app, already open in Visual Studio. After you've downloaded and installed the Surface Duo emulator, it'll add a section to the Start menu. Scroll down to find the Surface Duo folder, and notice there are 2 entries for the emulator. Choose the one for Visual Studio. It will take a few seconds to start, but when it's done, it will appear in the Visual Studio Build menu, ready to deploy to. I've already got it running, so let's save some time and open it up. This is a Surface Duo emulator running Android 10. You can see the black bar down the middle, which represents the hinge area between the 2 screens. I can view the app drawer by pulling up and notifications by pulling down. You can enable and disable rotation here if you need it later. I've pre-installed the Notes app for us to test, so let's see how it looks. On a single screen, it works perfectly. I can navigate between pages and add a new note. Editing and save. Notice the navigation bar at the bottom of the screen. That's the handle that can be used to span the app across both screens. As I drag, the shadow indicates where the app will land. So the app is working fine, but on 2 screens, everything is just stretched wide. I'm going to say that's initial testing complete, but it's not an ideal user experience for dual screens. Now that you've seen the emulator in action, step 2 of getting our app ready for Surface Duo is adding Android features that are well suited to dual screen devices, like drag and drop. Because apps can run side by side, there's lots of opportunities for sharing data with a simple drag, whether it's email to your calendar or other productivity apps, or anything you want to save and share. Because we're using Xamarin.Forms, I'm going to add an Android effect that hooks up the native drag functionality to the Notes list view and demo dropping into our sample app from GitHub. Let's head back to Visual Studio. Here's the Notes app again, and our goal for step 2 is to enhance it with drag and drop support. I've got our native drag and drop sample here, ready for testing. If you're editing text, you can already drag the selection for dropping, like this. So we're going to add drag and drop support to the list view, and we can drag the note from here as well. Because drag and drop implementations vary across the operating system Xamarin.Forms supports, we're going to have to integrate some native Android code. I'm going to use the Xamarin.Forms effect based on awesome work by Shane Newville. To start, I'll add the effect in common code and call it item drag and drop effect. It's a simple subclass that references the platform-specific Android code via a string identifier in the constructor. So I'm just going to paste it in, and there's the string. Now I need to actually implement it. So I'll add a class to the Android project and also call it item drag and drop effect. So once that's saved, again, there's too much here for me to type without errors. So I'm going to paste it in, and then we can walk through it together. So back to the top. The first thing to note here is the type aliases. We use these to make it easy to recognize them in code and not get confused with similarly named Xamarin.Forms controls. Next are these 2 assembly attributes. This is how the effect is resolved. These match the string in the constructor of the previous class. So we can just take a peek to check that. And notes.item drag and drop effect. Next come the onAttached and onDetached methods. These are the methods that the effect uses to get access to the native control that the effect is attached to. We haven't done that step yet, but as I mentioned, we want to apply the drag and drop behavior to the list view. So we can cast the control to a list view and work with its methods and properties. The first thing I'm going to do is add an onClick listener, which is a class and a method in this code. And we're going to set long clickable to true to make sure that that gesture actually gets recognized. The last step in the effect is the actual dragging code. It uses the parameters passed in through the long click listener to recognize what we're trying to do. We get the item that was clicked on. Notice that it calls toString on that model. We create a clip data object for dragging. We create a view to represent the drag, and then we start the drag operation. This is the simplest version of drag and drop on Android, but it'll get us to where we want to go for now. Now, notice creating the clip data object called toString on our model. I need to quickly jump over to our notes CS file so that we can implement toString to include the data that we want to drag and drop. So open the models folder, jump in there, and I've got a toString method handy to paste right in. Now that we've implemented the effect, we need to apply it to the list view control in the XAML that it appears on. Open up the notes.cs, notepage.xaml.cs, and the first thing we need to do is declare a namespace to reference the XAML class we've created. So XML-NS, and I'm going to call it effects. And we can use IntelliSense to help us find this assembly. And now we can just paste the effect XAML in, and we've referenced the item drag and drop effect. Now when I run the app, it's going to support dragging and dropping from the list into other applications that support text drop. Let's see it in action. So on the right, I've started our drag and drop sample. And when the application loads, notice when I put the mouse down, it pulls over and I can drop right into the other screen on the emulator. So that's all I'm going to do for step 2. We've enhanced the application to support dual screen operations that would also help you on other Android devices. We can customize it further and add code to support dropping items into the notes, but I'll leave that for you to try. With drag and drop implemented, it's time to consider step 3 on our path to dual screen awareness. Step 3 is working on enhancing the app for dual screen use, especially when it's spanned across both screens. Microsoft has built a control specifically to help with this scenario called the two-pane view. It's available on Windows, React Native, and Xamarin, and helps build adaptable layouts that work on dual screen devices, as well as single screen phones and larger screens like tablets and desktops. The two-pane view control contains 2 views and a wide variety of customizations to control how they're rendered. On small and large single screens, both views can be visible at the same time. There are a number of properties to control whether they're side by side or top and bottom. These screenshots are from the two-pane view sample app and show how different layouts can be achieved. When spanned across both screens on the Surface Duo, by default, the panes are shown one per screen, which is the behavior that we're after. It's also possible to selectively hide and show each pane and replace the views in each pane. Basically, it's super customizable and it can help you not only with dual screen compatibility, but potentially also getting your app onto tablets and desktops. To add the two-pane view to the Notes app, I'm going to need to do some refactoring. Currently, the app is structured as 2 content pages using the navigation system to move between them. When the app is spanned, we want the views within those 2 content pages to appear side by side. So I'm going to extract the XAML into 2 content views. This will involve some renaming of classes and types. And once that's done, I'm going to add the two-pane view control into a new page and embed the master and detail views inside it. Finally, I'm going to need to shift some page content methods around that were originally in the master page and move them into two-pane view. Sounds complicated, but we're only going to affect about a dozen lines of code. So let's begin. Back in Visual Studio for step 3, optimizing for dual screens. First, I need to add the Xamarin.Forms dual screen NuGet, which will give us the ability to add the two-pane view control to the app. I'll add it to both the Common Code project and the Android project. So just need to search for it, and there it is. And we'll add it to both of those projects and click install. A couple of dialog boxes later, and we should be ready to go. Some of the behavior of the dual screen controls, such as detecting when the app has been spanned, requires a reference to the Android activity. So we also need to add an init method in the Android project. I'm going to open up the main activity.cs and just add dual screen service.init. And we're missing a namespace there, but command period, helps us out. The XAML class, now I'm going to convert the 2 content pages into views. Start with the notes page, and then I'm going to rename it in both places to reflect the fact that it needs to be a content view. So first rename notes page using the refactoring tools to notes view. And then the inherited class, we need to change that as well to content view. And now we're going to skip over to the XAML and make the same change. Now that this is a content view, some other attributes aren't valid. So we're going to delete the title and Notice that the toolbar item is also not valid, but we're going to need that later, so I'm just going to comment it out for now. We need to follow those same steps for the notes entry page. So first use the refactoring tools to rename it, and then the parent class, and finally the XAML. So content view, and once again, title becomes invalid and we need to delete that as well. Now we're done the first step, turning our existing pages into views. But the app isn't going to build yet because we still don't have any content pages for the app to start up with. To fix this, I'm going to go and create a new content page. So in the shared code folder, add a new item, and we're going to just call it main page. And here comes our XAML. In the new main page XAML, the first thing I'm going to do is add a namespace for dual screen so that we can use the two-pane view control. So let's call it dual screen, and we can use IntelliSense to find the namespace for us. Way down the bottom, Xamarin starts with an X. And we also need a namespace for the views. So just call it templates, and we'll use the current assembly. While we're here, let's set the title on this new page. Now I can copy in the two-pane view definition, replacing the default stack layout, and we can have a look at what it does. So here, just delete that. And here's the two-pane view. There are two parts, pane 1 and pane 2. In pane 1, I'm using the namespace I just defined to set the content to the notes view that we just converted. In pane 2, I put a stack layout just to show that you don't have to use a predefined view. You can just drop XAML right in there. When running the app, this will initially show a label saying pick a note. But once you've selected an item, it'll replace with the note entry page details view. That's all the markup we need. But recall I just commented out the toolbar on the other page. I'm going to jump back there and grab it and put it in our new main page. And don't forget to uncomment, Control-K-U. Because I've moved the declaration, we can also copy across the event handler. So let's go back over to the code behind, and it's already red, so we know there's a problem. So cut and move it over to our new main page code behind. So the navigation is no longer valid because we've taken these out of their old content pages. Instead, I'm going to just put this new note entry view directly into the two-pane view, and we can get rid of async because we no longer have any asynchronous methods. And finally, command period helps us out again with the namespace. Because I moved the declaration, I needed to shift that method across. We'll follow a similar pattern with other methods a bit later. Now that we've got our two-pane view in place, I want this to be the startup page of the app. So I'm just going to put new main page right into the app class. We're now about 2/3 complete. All the layout and visual changes are done. And we now have the old user interface converted into two views, which are encapsulated in the two-pane view and ready for dual screen display. We still can't compile and run though. There's some other logic in those code behind files that we need to update, specifically to make sure that the navigation works as expected. So let's start with the note entry view. It's simple, there's only two event handlers. So starting with the save one, you can see again, it's referencing the navigation framework and that's no longer in use. For now, I'm just going to comment it out and put a to-do in there to remind me that we need to fix it. Scroll down, and I'm going to do the exact same thing with the save method. Comment out the navigation and just a to-do note so that we can fix it later. Popping over to, we just need to remove the async, and popping over to the notes view, you can see that the onAppearing method is a red squiggly. That's no longer valid as well. This is because, again, we converted it from a page to a view. So we're going to take this method and put it on our new main page. So there we go, copy and move into the main page, and paste. Some of the types need using statements. Again, control period is my favorite shortcut for that. And I'm also going to update the binding because now we're using the views embedded in the main page. I'm just going to set the binding context directly. Now we need to jump back into the view to pick this up. So notes page XAML is already open. New list view, attribute, item source, and just set the binding to dot. Now the list is wired up again. We can address the rest of the methods in the notes view code behind. Now, all of the red here is a good indication that something is wrong. Once again, because we refactored the pages into views, they're no longer able to be navigated to directly. I'm going to comment this out once again and put a to-do here so that we can come back and fix it in a minute. Now we have a few different to-dos in the code, all relating to the old navigation implementation. The way we're going to solve this is by moving all the state management into main page and let it act as the navigation controller in air quotes. For that to work, I'm going to create a current property on main page that will make the methods accessible to the views. So let's skip back over to main page and public static main page current with get and private set. I can hear people already crying over the tight coupling here. Rest assured, you can also accomplish all of this with MVVM, and we have great samples that demonstrate that. But this demo is just all about speed. Now that we have access to the main page current class, we can implement the to-dos that we've been putting in the other pages. Let's go back to note entry page. And what's the behavior that we want to put here to replace the navigation? So because the two pages are side by side, when we finish saving something, we just need the list to be refreshed on the other side of the screens. So let's copy the code that we already have that does that. And I'm just going to refactor it out into its own class method, call it refresh data. And that's actually, we'll make it public, all that we need to do when the save method is finished. So switch back over to the notes entry, and we're going to just call main page dot current dot refresh data. The same. There we go. And just get rid of the to-dos. The side effect of the two views being visible is there's no swapping screens one over the other. So we need to also fix the state of those two screens when saving or deletion is done. So when a save is done, we want to update the model so that its file name is updated and we can keep editing as that pane remains visible. And when we're deleted, we actually need to clear out the model. And so we're going to set it to an empty note class. There we go. And now we've fixed all of the compile errors in this page. The remaining tasks are in Notes view on the item selected handler. We want the two pane view to update the second pane details. So I'm going to add methods to handle this in the main page. First, I'll copy the onListView item selected method into the main page, and I'll update the parameter to accept a note object. Because we've replaced the navigation view with two pane view, I'm going to set pane to directly with the binding context set. Now back in the original method, we'll call this main page current and pass the note. So there we go, and that's item selected complete. And oops, need to make that note. To summarize, because we converted these content pages into views and removed the Xamarin.Forms navigation, we've copied the logic from their code behinds and centralized it into the main page, where the navigation occurs by setting the panes in the two pane view. These two methods in the notes page master view, when something's been selected or a new day is requested. It's all handled in main page. There, it creates a new view for the second pane and assigns a binding context or creates a new one. Refresh data is called every time something is saved or deleted and updates the list view with the most recent data, which is effectively the same as navigating back to the list. So now we're really done with the refactoring. We have updated the XAML and converted the two content pages into views. We've added a new page with the two-pane view, and we've updated the code behind to replace the old navigation states on the main page. It's time to hit run and see the two-pane view in action. If you look closely, the first thing you'll notice is the two views are now side by side, even on a single screen. The list is on the left and the detail view is squeezed on the right. If I click an item, you can see the detail view on the same screen. It's not really what we want. But the goal for now is to test dual screen behavior. So if I drag the navigation bar and span the app across two screens, you can see it works largely as you'd expect. Clicking through items on the left shows the details on the right. I can add a new item and I can delete it from the list. At this point, we've achieved our goal of supporting the Surface Duo with the app spanned across both screens. But if I drag back to a single screen, it seems like we'd want the user interface experience from before. If I quickly drag the emulator to the side, we can actually play around a bit with the XAML using Xamarin.Reload. So I've got the XAML shown here. And if I add min wide mode width, say, and set it to be 600, hot reload is going to instantly update the emulator. And you can see that now, instead of side by side, the two panels are top and bottom. And I can change a different property and say tall mode and wide mode configurations and set them to be single pane. And when I do that and hit save, hot reload is going to show me that actually I've hidden the second pane altogether. And that's the kind of behavior that we want. So in single screen, we want to show one pane or the other, which is going to be our trick to reinstating the master detail navigation. Here's a visualization of the Notes app on two screens, where it now works as intended. But the default behavior of the two-pane view means that the master and detail now appear side by side on a single screen, as you can see in the center image. To restore the original behavior, we can use the two-pane view mode configuration and pane priority feature. When the app is spanned across two screens, we'll set the mode to be left-right and top-bottom so that both panes are shown. When the app is running in a single screen on any device, the mode will be single pane and only one view will show at a time. Which view will be visible will be dynamically set using pane priority. To restore the single screen navigation we want, only a few additional changes are required. To start, I'm going to update the main page so that we assign the note entry view detail in XAML. The old code was creating a new view every time, and implementing the empty state would be better done with a view model. So now, in the code behind, we only need to change a few lines. First, because I added the note entry view in XAML, I can tidy up the added method to just reset the view binding. Same applies to the item selected method. So I can delete a lot of code and just assign the new note correctly. And get rid of those, and we're done. Same applies to the item selected method. I can change the view into a binding context and just get rid of the code. Now, add the Xamarin.Forms dual screen namespace. And in the constructor, wire up an event handler for the two-pane view layout changed event. This will enable the code to react to the app changing from single to dual screen. So we're just going to plus equals and create that method. So before we implement it, there's a simple check to see whether the app is spanned, and that uses the dual screen info class. So we're just going to quickly paste in that check, device is spanned, using dual screen info. If you ever have any troubles with this method, it's probably because you forgot that init method we mentioned earlier. Now that we've got the device spanned, we can implement the check that responds to any change in layout. And if the device is spanned, we set the mode to left, right, top, bottom. And if we're on a single screen, we always want to use single pane. Now we've set the pane priority, in all of our interactions, we'll get the behavior we want. That's all we need to restore the single screen user interface. However, there's one last tweak I'd like to add, and that is back button support. When we stopped using Xamarin.Forms navigation, we missed out on going back and forth via the hardware. By implementing on back button pressed, I can catch when the user is trying to go back from the detail screen and direct them to the master list. It's a small touch, but it increases the feeling of quality. And it's time to hit run and test our app. While we're waiting for this to build, it's probably a good time to mention all of this work has been done in Visual Studio on Windows, but all of these demos, the Service Duo emulator, all work on Mac OS with Visual Studio for Mac. So here's the final app. Transitioning between views as you would expect on a single screen, list, detail, list, detail. I can add new and create a new note. If I span, it works great too. List on the left, details on the right. So this is our demonstration completed. We've managed to implement dual screen support in the Notes app. Even with copying code, we've done about all we can fit into this time slot. If you'd like to continue learning with this app, as part of the resources, you'll find both the original sample that we've worked on today, as well as an updated version that takes the dual screen conversion even further with the collection view control, darks and light themes, and more. You can use both versions to continue learning about the process of enhancing apps. I hope the theory behind this refactoring has made some sense. There's still a lot more that can be done to help apps really take advantage of the Surface Duo. If you're enhancing your own apps, let me suggest some. First, hinge angle awareness is something you might want to build into your apps. It won't be for everyone, but there's an opportunity for creative thinking. Widgets have been available in Android for a while, but they're ideal for the Surface Duo because they can remain visible when you're using another app. Think about what your information your customers might like to see at their fingertips. First run experiences are also becoming more common. Take the opportunity to highlight app features, including dual screen enhancements, to help with discoverability. Also consider connecting to Microsoft Graph and authentication services. You can help your customers stay secure and share across devices. And finally, advertise. Make sure your customers and potential customers know you support Surface Duo. Before we go, I wanted to leave you with a bit of dual screen inspiration. The Xamarin TV app shown here is a great example of dual screen MVVM. It takes advantage of visual state tick triggers to declaratively manage the two-pane view layout and just generally offers a great experience. You can find the code on GitHub or linked from the docs. Another Surface Duo demo you can try is this food delivery app. It uses MVVM as well and highlights how you can use the Xamarin.Forms collection view to create dynamic user interfaces. And it's also available on GitHub. That's it for now. Here are some useful links. I'm sure you've all visited docs.microsoft.com before. So if you can remember the first link, microsoft.com/dual-screen, you can find your way to everything else, including the emulator installer, the helper library, two-pane view layout, and sample code. If you give the tools a try, please let us know what you think. You can comment on GitHub or tweet at Surface Duo Dev. Thanks for joining me. I look forward to seeing what apps you build for Surface Duo.